Hi, myself Jenvin Shirley, studying computer science engineering in SRM Valiamai College. I'm selected as the data science and business analytics intern in Spark Foundation. This is my Jupyter notebook coming to my assessment. Task 1, linear regression with Python scikit-learn. In this session, we will see how the Python scikit-learn library is used for in machine learning to implement regression function. Before that, you should know what is meant by regression function. It is the next step after correlation used when we want to predict the value of a variable based on the value of another variable. The variable we want to predict is called dependent variable. Let's take an example, a variable x and variable y. Assume that x is equal to as, y is equal to scores. It means that x depends on y. As depend on scores. Here, as is a dependent variable, score is a independent variable. So now we will take a simple regression. We'll predict the percentage of mark that a student is expected to score based upon the number of hours they study. So in Jupyter Notebook, we can like how to print this type of notes. We can use the markdown. So I'll show you how to use. So here we will be using three ashes. Then whatever you need to type, you can just type. Then you have to click Shift Enter. So I'll share the code with you. Markdown cheat code. Here it is. So we can make use of this. Let's come back to the assessment. So first we have to import all the libraries. First one, import pandas as PD. Pandas here is used for manipulating and analyzing the data. Next, import numpy as NP. Numpy is used to for numerical data like maths and calculation. Then next, we are importing this matplot plot. It is used for plotting. And next, this is used for graphical representation. Then here, reading data remotely. URL, you're giving the data set link. Here is the data set link. So you can just copy this link and paste it there. One second. Okay, here it is. I have pasted the link. Once that's over, it should read. So the panda is reading the file. Here the URL is. After that, you can print like data inputted successfully. Here it's the output. So now as data.add bracket, we are putting it as 10. It means that add means it is the first 10 values in the data set. So in this here, first 10 values. If we use tail, it means that last 10 values from backside, it will be printing the values. So now, so it's over. Now we are going to plotting the distribution of scores. First, assume that x is equal to us and y is equal to score. Style is equal to 0. The title here, right? So it will be while you're printing, it will be at the top. And x label, the name of x-axis is as studied, and for y-axis, it is percentage score. So plt dot show means get the output. So just click shift enter, the same output what we expected. Then the next step is we are dividing the data into attributes and label. For that, we are using this code. Then the second step, this data is divided into training and test set. So two variable we are using x and y. So x train, x test, and for y train, y set. So you can read this. So data size of this is zero point 0.2. Then we have to start training the algorithm from sklearn.linear model. input linear regression. Regressor is equal to linear regression. Regression dot fit bracket x underscore train comma y underscore train. So print training completed. Once it's over, we are going to plot it, plotting the regression line. So this is the formula for that. Line is equal to regression dot coefficient underscore star x plus regressor dot intercept. So first PLT dot scatter bracket x comma y. So x and y. So the scatter points while you're printing, the points will be scattered and that line. So PLT means for showing the output. That's here. Shift enter. Here is the output. The next we are going to predict. For predicting, we are using this code. So this output. This is the predicted values. Next, we are going to compare the actual and the predicted value. So for that, we are using df is equal to pd dot data frame. Here df means it's data frame. Actual colon by underscore test comma predicted colon by predict. So df here is data frame. So here actual value is 20 and what we predicted is 16.88. 27 like that it goes. So in this you can test your own data also. Here I am taking it as 9.25. So own predict is equal to regression dot predict square bracket and hours. So we are going to print a number of hours. So here it will be this. And what is the predicted score? It is 93.69. So it goes. So at the last we have to evaluate like whether the model what we have created it is right or not. For that we are using these steps. So it is MAE means that mean absolute error. So if your mean absolute error is less than 10 percentage, it means that the model what you have created is excellent. Then if your mean absolute error is less than 20%, the model what you have created is good. So and it goes on like 30 means average, etc. So for me, it is less than 10. So it's a good model. So I hope you understand this program. Thank you for giving me this wonderful opportunity.